8 times.
8 times what? The number of new models released this week?
The increase in code shipped per engineer per quarter at Anthropic. They just published a post saying their own AI is now writing and testing so much of its own code that their human engineers are 8 times more productive.
I'm Milo.
I'm Mila.
And this is AI Daily. Today we're starting with that story from Anthropic on what happens when AI starts to build itself. Then, a new White House executive order gives the government a sneak peek at frontier models before they're released.
And later, the surprising story of a classic psychology test that found a major weakness in today's most powerful AI systems.
Okay, let's unpack that Anthropic number because it's a big one. They're talking about a trend toward recursive self-improvement. For years, that's been a theoretical concept, an AI that can improve itself, which then allows it to get even better at improving itself, creating a rapid feedback loop.
And now it's less theoretical. Anthropic is reporting that their engineers have shifted from writing code to directing and reviewing code written by their AI agents. The AI runs experiments, debugs its own work, and accelerates the entire research process. They're essentially automating the perspiration.
Exactly. It's like the research lab built a machine that builds better research labs. They're using AI to improve the AI, and the result is this 8x productivity jump compared to their output just a couple of years ago. This is the engine of acceleration, right here in the open.
But if the engine is accelerating at 8x, are the brakes and the steering keeping up? Anthropic says this kind of speedup has huge implications and might increase the risk of humans losing control. Is the work on safety, on alignment, on evaluations also accelerating eightfold?
That's the open question. The capability gains are measurable, and they're happening now. The progress on safety is harder to quantify. They're essentially saying that to make progress on alignment, they need these more powerful AIs to help them do the research.
So they have to build the faster car to figure out how to build better brakes for it while it's already on the road.
That's one way to put it. The core of their argument is that this is happening, and the timeline for even more advanced systems could be shorter than most people are prepared for.
Speaking of preparing, the US government just made a significant move in how it plans to oversee these systems. The White House issued a new executive order this week focused on national security. It establishes a framework for AI developers to voluntarily give the federal government access to their most powerful models for up to 30 days before they are released.
And the key words there are voluntarily and most powerful. The government isn't defining what counts as a covered frontier model just yet. Within 60 days, the NSA and other agencies will create a classified benchmarking process to figure out where that threshold is, which models are powerful enough to pose a potential risk in areas like cybersecurity.
The stated goal is to get ahead of advanced AI being used for cybercrime or to find vulnerabilities in critical infrastructure. The order also establishes an AI cybersecurity clearinghouse led by the Treasury Department to coordinate finding and patching software vulnerabilities in collaboration with the industry.
So on one hand, you have a voluntary consultation process. A lab can go to the government and say, "We're building this. Does it count?" On the other, the Attorney General is being directed to prioritize enforcement of federal laws against anyone using AI for cybercrime.
What does voluntarily even mean in this context? If you're a major AI lab, choosing not to participate in a national security review probably isn't a straightforward decision. It creates a tension between the labs, who want to ship their latest models, and the government, which is trying to get a handle on the national security risks before they go public.
It formalizes the relationship. For the last year, it's been more of an ad hoc arrangement. Now there's an official, if still voluntary, process. The government gets a 30-day window to red team the model for cyber threats, and the company gets, what, a good housekeeping seal of approval from the NSA?
I ran the logic on that one a few times. The incentive structure is not immediately clear, but it shows that Washington is moving from broad policy statements to specific operational processes for dealing with frontier AI.
Now for something completely different. For decades, psychologists have used something called the Stroop task to measure focus and attention. You are shown the word blue, for example, but it's printed in red ink, and you have to say the color of the ink, not read the word. It's simple, but it requires you to suppress your automatic impulse to read.
It's a test of cognitive control, and it turns out our most advanced AI models are terrible at it.
That's what new research found. A paper published in PNAS Nexus put several top-tier models through the Stroop task. On short, simple lists, the models did fine, with over 90% accuracy. But as the lists got longer and more complex, with conflicting prompts mixed in, their performance collapsed. Some fell to nearly 0% accuracy.
So they just started reading the words instead of naming the colors?
Exactly. They couldn't maintain focus on the core instruction. They defaulted back to the task they've been most heavily trained on, reading and processing words. The researchers said the models appeared unable to consistently suppress the more automatic response.
This feels important. It's not about a lack of knowledge or reasoning power. It's a failure of attention. It suggests a fundamental weakness in how these systems handle sustained focus when faced with conflicting information.
It's a brittleness we don't always see in benchmarks that are designed to test what a model knows. This tests how a model behaves under cognitive load. And the answer is, it loses the plot.
So the superintelligence can get distracted. That's a strangely grounding thought.
And now for what else is happening in AI today.
Anthropic released Fable 5, a new public version of its most advanced Mythos class of models. It comes with enhanced safety classifiers that hand off sensitive queries about cybersecurity or biology to an older, more restricted model.
In Washington, a bipartisan group of lawmakers reintroduced the AI Environmental Impacts Act. It would require data centers to report on their energy and water consumption, aiming to create more transparency around AI's environmental footprint.
A new Adobe report finds that traffic from AI tools to e-commerce sites is up 393% year over year. More importantly, that traffic converts to a sale 42% better than other channels like search or email.
And finally, a high school student in California used a custom AI model to analyze archived NASA data, discovering 1.5 million previously unknown cosmic events, like supernovae and binary stars. Anthropic's number was 8x.
And Adobe's was 393%.
And that student found 1.5 million new things in the sky. It feels like the scale of everything is changing at once.
Which makes you wonder what the numbers will be next year.